So the builders called in one of the most powerful cutter suction dredgers in the world, the caster. The caster's business end is a mega drill bit with 60 cutting teeth, each weighing over 20 kilograms. It's sometimes known as the spinning cone of death. But even with all this firepower, the Copenhagen limestone didn't surrender easily. It destroyed 200 teeth a day. 52,000 were replaced in total. The caster is more than an overgrown drill. It also acts as a vacuum cleaner. As it chipped away the limestone, it sucked up the debris. Giant pumps then forced the stones and water through 4 kilometers of pipeline, all the way to the island. The shards of limestone were so abrasive, they eroded the inside of the pipe. And moving all this rock and mud involved an additional challenge: protecting the environment. The environment is especially vulnerable in the shallow Øresund Strait. The biggest threat is from plumes of debris. Clouds like these can kill huge areas of the seagrass that feeds and shelters marine life. For both Denmark and Sweden, harming the environment was a deal-breaker. They made a pact that if more than 5% of debris was spilled, all dredging must stop. A decision that would put the entire project at risk. 5% spill doesn't sound like much, but it equates to 340,000 cubic meters of misplaced rock. Avoiding spills required a balance of speed and caution, but the dredging workers succeeded in working within their environmental limits. But they were about to face another danger, one that would threaten their own lives. The 25th of November 1995 was the 30th day of dredging for the Øresund link. Digging up the 7 million cubic meters of seabed seemed to be a fairly straightforward assignment, and the crew thought everything was going smoothly. But dredging had just become the most dangerous part of the entire project. Workers didn't know it, but they were just centimeters away from death. The problem started when the Chicago accidentally scooped up a dangerous payload, a bomb that was ready to explode. It then dumped it onto a barge covered in mud. Nobody knew it was there. If anything had bumped its detonator, 36 kilograms of TNT would have blasted the barge and crew to pieces. How it ended up here is a story that dates back 60 years. In May 1945, Denmark was celebrating the end of World War II. The British Royal Air Force put on an air show over Copenhagen harbour with live bombs. Some sank without exploding, and now, 6 decades later, they're more deadly than ever.
Even though the bomb is maybe 50, 60 years old, it can still work as designed. So that's why it's dangerous, always. If the bomb has gone through some corrosion and there has been some deterioration of the explosive, it may have become even more sensitive, and in that case, even more dangerous.
Equipment inched closer to the bomb. Then, just in time, someone on the dredging team spotted it. The Royal Danish Navy was called in to remove, defuse, and explode the bomb. These bomb experts knew better than anyone that the outcome could have been tragic.
If they hit the bomb with their dredgers or with their buckets or whatever, and it went off. Somebody had been killed.
It was a narrow escape for the crew and the schedule. With the bombs gone, dredging resumed. But the relief was short-lived. Soon, more bombs were discovered. Luckily, no one was injured, but the schedule suffered huge setbacks. Now, no area could be dredged until it had been swept for bombs. All 16 were removed and destroyed. Being safe was more important than being on schedule. Long before the bombs had been discovered, and even before a dredger had dipped its first bucket, the Øresund engineers knew they faced a unique set of very difficult challenges here. The water separating Denmark from Sweden was 16 kilometers across, but the cultural gap between the nations was much larger. They were two very different countries, with different languages, currencies, and ways of doing just about everything. Cars didn't even drive on the same side of the road until the 1950s. And trains still don't, passing on the right in Denmark, but on the left in Sweden. They also run on different electrical voltages and use different signals and radio frequencies. None of this had mattered before, because the countries had never been connected. But now it was a puzzle that needed to be solved before the bridge could open. Engineers needed to design a computerized Rosetta Stone so that the different train computers could communicate. They also needed to create a standardized wording so that all train operators would understand spoken instructions. And designers had to invent electrical equipment that would switch trains from 25,000 volts to 15,000 volts on the fly. The solutions were so complicated that every new train would need to be tested without passengers before it could use the Øresund link. But there was also a problem with emergencies. Firefighting equipment in one country didn't fit equipment in the other. The best solution was to put both couplings on every water hydrant. Every little detail required collaboration. The countries didn't even use the same name for the strait. The word Øresund is a mixture of the Danish and Swedish versions. While some of the team worked on a name for the link, others continued to work on how in the world to build it. The plans called for a submersible tunnel bigger than any ever made before. The first step was to construct a factory to make tunnel parts. The idea was to make the tunnel in 20 segments, then assemble them in the trench. Even the segments would break world records for size. They were 175 meters long, 38 meters wide, and 8.5 meters high, with 2 tubes for traffic, 2 for rail, and 1 for emergency escape. One enormous segment had to be created every month for 20 months. In Denmark, the tunnel construction began with 40 million kilograms of reinforced steel bars. These were bent and welded into a huge steel cage, then slid into an enormous mold. Then, the massive framework, 1.5 trillion liters of concrete. Of all the monstrously large parts of the Øresund link, the tunnel elements were by far the biggest. They were nearly the length of 2 football fields and as high as a 3-story house. A single piece weighed an astronomical 55 million kilograms. Moving them was an enormous and dangerous challenge, one that triggered the most catastrophic accident of the entire project.